So this is just a quick little tutorial on the Hardy-Weinberg formula. Remember that there are 5 criteria to meet the Hardy-Weinberg principle, and that Hardy and Weinberg were mathematicians, and their whole math formula was based off of proving a population is not evolving. So in their math, they used P plus Q equals 1. P is for somebody that is homozygous dominant. In other words, both alleles are the dominant characteristic. Q is if the person is homozygous recessive, both alleles recessive. So an example of that would be if you're Q and you're recessive, if you have red hair or blonde hair, the only way you got that is if you had both recessives are from both parents. So in the population, there are 2 ways of looking at the formula. If they only want to know about the alleles, about the number of people that are dominant or the number of people that are recessive, the formula is P plus Q equals 1. And we'll start with that. So if I had a population, if I looked at flowers, and 80% of them, I told you straight up front, were dominant red flowers, and 20% were completely recessive flowers. I would use, and you were just looking at the statistics of that, I would use this top piece of the formula here, where it is P plus Q equals 1. And if 80% were completely, I've got to get my finger over here, dominant, the P is for dominant, it would be 0.8%. And if I had 2% completely recessive, it'd be 0.2. And you can see if you add the completely dominant and the completely recessive together, it equals 1. And that's what their formula up here is for on if you're just looking at the alleles over here. My fingers are going backwards here. That is just if you're looking at allele frequency. If they ask about not the alleles, but your genotype frequency, we have a different formula. That is P squared plus 2PQ plus Q squared equals 1. Whereas the P squared is for the completely dominant trait. Let me see if I can get them backwards here so my fingers are not going to help. And Q squared is for the completely recessive trait. Now, 2PQ is the first time we've seen P and Q. That is for the person that's the mix, 1 dominant and 1 recessive trait, heterozygous. So again, this formula is in chapter 23 textbook in your bio book, and for allele frequency it's just P plus Q, but if they want the genotype, you have to use P squared plus 2PQ plus Q squared equals 1. And then all you do is substitute in what numbers they give you. So again, if we stay with the 80% of flowers being dominant, or 0.8, and 20% of the flowers being completely recessive, 0.2, we can then substitute in the numbers and find out what percentage of the population is heterozygous, or that PQ. And in this case, I already knew that my completely dominant, my P, was 0.8, and that's going to be squared. What I didn't know, I ended up finding out through algebra, was the 2PQ. And then I knew what my Q squared was, my 0.2 squared. And so when you figure it out, I still am going to end up adding up to 1. If I go 0.64 for my 0.8 squared, plus my 2PQ would be 0.32, plus my 0.2 is my recessive, 100% recessive trait. And if I add that all up, I get to 1. So again, there were 2 ways of looking at Hardy-Weinberg. There were 2 separate formulas. The first formula, if the question asks just what the allele frequency is P plus Q equals 1. And then they've got to give you at least P, or they have to give you Q. Otherwise, you can't figure that out. And then you would just plug in what the numbers they give you are. If the question is asking, instead of alleles, if they're asking for and again, alleles would be your phenotype piece. If they're asking you for your genotype, the capital R, small r, or other characteristics they give you, remember the genotype is going to be your letters in that Mendelian Punnett square. If they're asking for genotype, you're going to use the second formula. P squared, that's your completely dominant characteristic. Your heterozygous is the PQ, and a completely recessive would be the Q squared. And again, all you would do is plug in whatever numbers they give you. Usually they'll give you either the dominant or the recessive, and A equals 1, and you can figure it out from there. So again, using the same statistics that I gave you above, if we had flowers that were 80% of them were completely 100% dominant and 20% were completely 100% recessive, I can then plug in, and I want to know what percentage are going to be hybrids, or that heterozygous mix. And in this case, it could be like a codominant color. So if I already know it's 80%, I would plug in the 0.8 squared. If I know it's 20% recessive, I would plug in the 2.2 squared for the P, and then I can figure out what the heterozygous is. And I'm going to put online an entire worksheet and a Bozeman tutorial also on Hardy-Weinberg. But that's the quick view of the two ways of calculating out a Hardy-Weinberg formula. Again, Hardy and Weinberg's whole theory was that this is based off a population that is not evolving. Thank you.